Today I am going to present the topic difference between NAND and NOR in CMOS. Before understanding NAND and NOR gates, we should first know about CMOS technology. CMOS stands for Complementary Metal Oxide Semiconductor. It is one of the most widely used technologies in digital electronics and VLSI circuit designs. CMOS circuits are made using two types of transistors called CMOS and NMOS transistors. PMOS transistors conduct when the input is low, while NMOS transistors conduct when the input is high. By combining these two transistors properly, different logic gates can be designed with very low power consumption. CMOS technology is very popular because it provides low power consumption, high noise immunity, high speed operation, and better reliability. Almost all modern electronic devices such as computers, mobile phones, calculators, microphones, microprocessors, and memory chips use CMOS technology. Among the different logic gates, NAND and NOR gates are most important because they are called universal gates. A universal gate means any digital logic circuit which can be designed using only NAND gates and NOR gates only. Although both gates are built using PMOS and CMOS transistors, their transistor arrangements and working principles are different. The difference affects the output conditions, speed, and operation of the circuit. Now let's study the CMOS NAND gate first. This slide explains the CMOS NAND gate in detail. In a CMOS NAND gate, the PMOS transistors are connected in parallel in the pull-up network, and the NMOS networks and the NMOS transistors are connected in series in the pull-down network. The term NAND means not AND, so the output of a NAND gate is as opposite as of an AND gate. Let us understand the working condition carefully. Case 1. If both inputs are high, then both NMOS transistors are turned on. Since they are connected in series, a conducting path is formed from the output to the ground. At the same time, both PMOS transistors are turned off. Therefore, the output becomes low. Case 2. If any one input becomes low, then at least one of the NMOS transistor turns off and breaks the path to the ground. At the same time, at least one PMOS transistor turns on because the PMOS works with very low power input. This connects the output to the power supply and the output becomes high. So we can say the output of a NAND gate becomes low only when all the inputs are high. The parallel connections of PMOS transistors help the circuit pull all the output high quickly. Because of this, CMOS NAND gates are usually have better speed and are easier to design compared to NOR gates. NAND gates are widely used in arithmetic circuits, processors, memory circuits, digital systems. They are one of the most important used logic gates in VLSI design. Now this slide explains the CMOS NOR gate. In a CMOS NOR gate, the PMOS transistors are connected in series in the pull-up network, and the NMOS transistors are connected in parallel in the pull-down network. The term NOR means not OR, so the output of a NOR gate is the opposite of an OR gate. Now let's understand its operation. Case 1. When both inputs are low and PMOS transistor then the PMOS transistor turns on. Since they are connected in series, a conduction path is formed from the power supply to the output. At the same time, both NMOS transistors remain off. Therefore, the power output becomes high. Case 2. If any one input becomes high, the corresponding NMOS transistor turns on. Because NMOS transistors are connected in parallel, even one on transistor can connect the output to the ground. At the same time, one PMOS transistor turns off and breaks the path from supply. Therefore, the output becomes low. So we can say the output of a NOR gate becomes high only when all the inputs are low. Since the NMOS transistors are connected in parallel, the pull-down operation becomes faster. However, the series connection of PMOS transistors makes the pull-up operation slightly slower compared to the NAND gate. NOR gates are used in control circuits, memory units, sequential logic circuits, and digital communication systems. So the NAND gate and NOR gates are very important CMOS logic gates used in digital electronics. The main difference lies in the arrangement of PMOS and CMOS transistors. In NAND gate, PMOS are parallel and NMOS are in series, whereas in NOR gate, the PMOS are in series and the NMOS are in parallel. The output condition is also different. NAND gate gives low output only when all the inputs are high, whereas NOR gives high output only when all the inputs are low. Because of a better speed and efficiency, NAND gate are most commonly used in practical CMOS circuit designs. Both NAND and NOR gates are universal gates and form the foundation of modern digital systems. Thank you.